Hey everybody, welcome to this short video on summing an arithmetic sequence. So this is the same example that we previously worked through just kind of in text, but I thought a video might help you kind of grasp the concept a little bit more. So we are supposed to find the sum of this sequence right here, 5 plus 9 plus 13 plus 17, etc. So the first thing that you want to notice is that this is indeed an arithmetic sequence, and we can tell that because we add 5 to the previous number to get to the next number, and that's exactly the characterization of an arithmetic sequence. So we can find the closed formula for this. Remember, our closed formula is always going to be the first term plus the common difference, the d, which in this case is 4, times n. So here we have a sub n equals 5 plus 4 times n. All right, so that's the form, if you will, of each of these numbers in this sequence. All right. So the first thing I like to do when I'm looking at one of these is to think about what are the n values that we're looking at, kind of starting at the beginning with 5 all the way to the end of 289. So you'll notice that our 5 is actually a sub 0 because that's 5 plus 4 times 0, which is of course 5. So the first term in our sequence corresponds to n equals 0. Likewise, the 289, we can plug that in for a sub n and be able to solve for n by setting 289 equals 5 plus 4n. That is, of course, a linear equation. You guys should be able to solve that. Divide by 4 and you should get 71. All right. So what does that mean? That means the terms in our sequence go from n equals 0 to n equals 71. So what we care about is the total number of terms in our sequence. And that is, of course, going to be 72, since we're starting at 0 there. All right. So now we want to actually start adding the terms in the sequence. So what we're going to do is take our sequence right here, and we're just going to write the whole thing out with the pluses. 13 plus 17 plus ... Plus, I can use this form right here to know that the second to last term in the sequence is going to be 285. And then the last is 289. Of course, that's because it's 285 is 4 less than 289. All right. And so those added all together, we're going to call that capital S. We don't know what that S is. That's what we're trying to find. All right. So then right underneath that, we're going to write the same sum, but in exactly the opposite order. So we're going to start with 289 and then go down to 285, ... And then at the end here, we'll have a 9 and then a 5. All right. So what we want to do, these two sums are clearly the same thing because we're adding the numbers. You can do that in any order. But we want, so they're both equal to S. Now we're going to add them together. So on the left-hand side, we get 2S. Now we want to think about adding these kind of vertically, if you will. So for the first thing here, we get 5 plus 289 is, of course, 294. Likewise, 9 plus 285 is also going to be equal to 294. And then you can see this term that I didn't write in here would be 281. 13 plus 281 is also 294. And basically, these are all 294s. So we have 2s is equal to 294 added to itself a bunch of times. All right. So the question is, how many times are we adding 294 to itself? Well, that's exactly what we counted earlier. The number of terms in our sequence is 72. So that tells us that 2s is equal to 294 added to itself 72 times, or in other words, 294 times 72. We grab our calculator to do that and get 21,168. So that's equal to 2s. Of course, we weren't asked to find 2s. We want to know what s is. So we grab our calculators again to divide by 2 and get that s is equal to 10,584. So this s is exactly the sum of this arithmetic sequence that we started with. I hope that helps. As always, let me know if you have any questions. Good luck. Take care of yourselves. Thanks.